So we're gonna get started. Thank you for being here, everybody. Thank you from the folks at home that are following us too. This is a collaboration. Is it a collaboration, Tasha? Yeah. This is the collaboration between the University of California Cooperative Extension of San Diego and the Irrigated Land Group. We are providing information and education to the members of the Irrigated Land Group. Today, I am very happy to announce that we have two outstanding, legendary, intergalactic speakers. I used to read
lost in space speaker.
I used to read Dr. Gary Bender's this is a true story, manual of avocado production. I don't know where I found it online somewhere, like this PDF, and I was training. Maybe one day I will also have the honor to be an advisor with the University of California, working in Southern California. And then that dream came true. Can you believe it? And now I'm hanging out with all these guys. Can you believe it? So it's a great honor for me to be here. And Dr. Gary Bender is going to start with an introduction to irrigation in avocado, and then Dr. Ali Montazar, that I also used to hang out with when I was at Davis. So it's a great honor to be with him today too. Is going to give us the latest on everything that there is to know about the research on avocado irrigation. I am an advisor for nurseries and floriculture, and I get a lot of people asking me questions about irrigation in avocado, which I know nothing about. So that's why I decided to bring these guys today to talk about the topic. So without further ado, Dr. Gary Bender, for your delight today.
Are we going to speak back here? Can we use the podium?
You can use the podium. I'm going to turn this around because the cable is not long enough, but you can see the screen on the, and you can click either the mouse or the clicker to go forward. You can push down. See, let me show you.
How do we go backwards?
Let me show you. You want to do here. Want to make sure that okay, so why don't you use these arrows down?
Okay,
Those two buttons in the middle.
very good.
One will take you forward and the other one will take you backwards.
Okay. Chip, is there a possibility I could just put it right here on the side and put this?
You know, the cable is not long enough, and we don't have another longer cable.
Okay.
So this is what we have got.
I got it. Okay. So I just wanted to, after that glorious introduction, I'm going to be talking kind of basic avocado irrigation. And I have been, one of these PowerPoints, I've been using this particular PowerPoint, and I've upgraded a lot through the years. I've been teaching classes to new avocado growers here in the county when I was with Extension. Gosh, since about 1991, I think. So we went up to all the way to 2019, and we stopped during the pandemic, and then we haven't got started again. And that takes the farm advisor to organize it. I'm no longer an advisor, so I'm just an old retired guy now. So, but I'm still teaching at Maricosta College, and just handed out the grades last week, as a matter of fact. So, and I'm gonna keep going there. I think that's fun teaching young students. So we're going to be talking. If I can get this to work. Oh, it's the down button. Okay. Avocado is a very interesting, different type of crop. It has a lot of feeder roots. Most of the feeder roots are in the top 8 inches of soil. So right below the leaf mulch are the feeder roots. And then they have some deeper anchor roots to hold the tree in place so that it tip over in the wind. Sometimes they still do, but that's what we're dealing with. And they extract a lot of water fairly quickly out of that zone. And it's necessary to keep the leaf mulch there. That breaks down and turns back into nutrients for the repeater roots. And that's the way they grew back in the down in the rainforest in Guatemala. They still do that here in California. We don't have very many deep roots. On one hand, it's not such a great thing for irrigation, but if you got sick trees, it's really easy to just reach down there, grab a handful of feeder roots and look at them real close. And if they're black or dark brown and break with a kind of a brittle snap, that's a good sign you probably have root rot. That's a phytophthora problem. And we've got some new chemicals. Arondis is the new one that right now that works pretty good, but I'm not talking about root rot today. So let's just move on here. They're inefficient at absorbing water. They don't have very many root hairs. A lot of trees have a lot of root hairs. This particular one doesn't. Many of our groves, of course, as you've seen, are located on steep slopes. And a lot of our slopes are decomposed granite soil. So that type of soil doesn't hold much water. Clay soils hold much more. Now, we do have some clay soil. So you have to kind of know what kind of soil you have so you can sort of judge how often you're going to have to water. And we'll tell you how to judge that in just a second here. And unfortunately, they're heavy water users. And we've had a lot of discussion over at Maricosta with the students. Why are we even growing avocados here? We're kind of in a semi-desert area here. Not like El Centro, but it gets hot and dry in the summer. And they do take a lot of water and they don't like a lot of salt. They are the most salt sensitive crop as far as tree crops that we grow in California. So we do have some issues. On the other hand, why do we grow them? I counter that with, this is actually the perfect climate for growing avocados. We can grow really good quality avocados. We have a good market for them. We're having trouble with Mexico, as you all know, because they're dumping fruit in here right now. But last year we got over $2 a pound. So now we're down below almost 90 cents a pound. Okay. There's got to be, I mentioned salt, there's got to be some over irrigation to leach that salt. So we'll show you how to calculate, and then you have to add some water, extra water to that and shove it down. I was talking to this gentleman over here. He installed a lysimeter. I do have a video on YouTube, I think, how to install a lysimeter. It's just basically a tube down there, and you put a suction device on there and pull water out, and you can check your salt content down there. But they have new devices nowadays. You don't really have to do that. They just stick it in and measure salt content of the soil. Here's the tip burn we get. This is chloride damage. And this is almost typical for our trees here. Now, if you get much more than this, you're going to have a real reduction in yield. Because those trees during the winter, in the early spring, they have to drop those leaves to get rid of the salt, grow new leaves, and that takes priority over fruit production. So they go to this drop, grow habit, and we've seen some grows go completely out of production when they're using their water from sometimes wells are just too salty. Here we go. Okay, so this is just a slide for students and some growers. I've had some growers come to me and say, why are we putting so much water on these trees? What's the water used for? And these are kind of simple things. Of course, photosynthesis, we need water for that. And there's our formula there if you're interested. And all kinds of secondary reactions. The trees are making all kinds of enzymes and plant growth regulators and things. All those require water. It kills the plant and maintains their plant structure. Our trees don't really wilt that well, but some plants wilt completely, and that's built in to save water. So you don't have this bright green leaf flat against the sun. It kind of wilts down and gets rid of some of that light and heat. Cooling is the big one. It's huge. We have a lot of water coming up, going through the stomates. Stomates are little holes on the bottom of the leaves. It keeps flowing. That's what's cooling this dark green leaf out in the sun. And if you stop that for some reason, if it gets for whatever reason, that can burn up the tree. One time, I don't know if you saw this on one of the videos I did, but we had a chemical company come to us saying, we have this new wax, you can spray the trees and it plugs up the stomates, and it stops using water, and you can save water. You can save 50% of your water by spraying this stuff on. And that was a long time ago when I was young and dumb. So I got one of the farm advisors from Riverside. So we worked together on this. I think we did 10 trees in the Rainbow area on a grower's property. We sprayed 10 with this, 10 without, and we're checking the soil moisture and everything. Yeah, indeed, it saved water, but the trees burnt up, the leaves burned up and all fell off. And the poor grower lost went out of production. They came back, but he was very unhappy with us, and he has never invited the farm advisor to come back on his property. So that's okay. Okay, so we consider that's the most important operation you can do. And I break it down into frequency, how often you irrigate, and then when you do, how much you irrigate. Okay, frequency. The theory is, at least my theory, maybe Allie will disagree, when 30% of your soil moisture is lost, that's when you want to refill the soil with water. Okay, so how are you going to do this? We need some way to check the soil moisture. And you can use a tensiometer. I'll show you a picture of that if you don't know what that is. And the tensiometer, we think on at least about decomposed granite soils, 30% moisture loss equals about 20 to 25 CBs on the tensiometer. Just a shovel, just keep checking, go through there with your ATV or your Jeep or something. Just dig in the root zone, probably about a shovel handle length away from the sprinkler. Check the soil moisture. And if it's too dry, if you make a ball in your hand, open it up. If it's way too dry, it will all go through your fingers and not stay as a ball. If you can squeeze water out of it, then that's probably a little too wet.
How far down would you want to check?
I usually go about 8 to 12 inches, something like that. Gypsum blocks. We have various companies producing these. One of them is Watermarks, produced by the Aerometer Company in Riverside. They work great. They have two electrical leads. Electricity goes through the gypsum and will tell you how wet your soil is there. And fortunately, they're reading at the same numbers as the tensiometer. And sometimes we have these little portable electrical meters that sometimes the farm supply companies will want to sell you. Those are really for pots and nurseries, and they came out with a big one, and it was a long deal like this, and you press it in, press the button, and it'll read how dry your soil is, which I thought was pretty cool. I think I spent $350 on this. And I think the second time out in Palma Valley, I hit a rock and bent the tip over, and it stopped working. And that was it. $350 down the drain. So I think our soils are a little too rocky maybe for that. This is just a picture I tried to show in 12 inches of soil. We get about 2 inches of water. If you take all the water out of 12 inches, when you get down to 0.6, that's 1/3 of that. That's how much you want. That's when you want to irrigate. So just to kind of give you a visual picture on that. Okay, so tensiometers. I've talked about these before in our classes. They've been around since I think the early 1950s, and it's just basically a tube. I'll show you a picture here. You don't know what it is. Filled with water, with kind of a porous clay cup at the bottom, and water goes in and out. As the roots, they're next to this porous clay cup, as the roots pull water, it tends to pull water down this tube and turns the dial on the tensiometer, and you can tell your wind of water. There are some disadvantages to it. It takes a lot of work just running around trying to get all these numbers. They will get air bubbles in them. You got to pull them out, put them in a bucket and repump them to get them charged up again. You have to do that at least once a year. Sometimes our pickers step on them, break them, things like that. So I've got here set it about 8 inches below the soil surface, and then set another one 20 inches deep if you can. The deep one is just to watch, see how things are going down below, but you're irrigating to the 8-inch. There's no power involved. There's no batteries, no wires. The watermarks, there is power involved. They have you can run them on a solar battery or wire them to a box. And our high density Avocado Grove Valley Center, we had all those wired up to one box at the top of the hill. You can press different buttons and see how dry your soil is on that hill. Okay, I just mentioned maintaining them and protect them from the pickers. Yeah, we found out that for some reason, when they come off the ladder, they like to step on these things. So we put a Home Depot bucket over the top of it and let them step on the bucket. Okay, so if they get too dry, they'll break suction. If they get above 80 centibars, they'll break suction, and then the needle will flop back to 0. And this is a warning I've given our growers that if you leave for 2 weeks on vacation and turn everything over to your son or your grandson and let them irrigate to this, you'll come back and you'll see the needle flop down to 0. We have seen that a lot of times, so be a little careful of that. Here's your tensiometer. This is just a little gypsum block. I believe this is a watermark here. And you have 2 leads coming up. You can get a little reading device, go around and touch those 2 leads and get a reading, or you can wire them to a box, like I said, or they have this new Irrimesh system where they'll collect it to one collector, and you can go, I think it goes up to a website, and you can download that on your computer so you can read everything from your desk in your office if you want. We have some more expensive methods that capacitance probes we do use. Some companies use it, the numbers are a little different than what we know about the tensiometers and watermarks. And so I've always been a little hesitant to use those, but we do have companies using neutron probes. You won't be using that as a grower. This is an example where they've irrigated a little bit. Let's drop these numbers here a little bit. They've irrigated for a much longer period of time. They dropped it all the way down to almost 0 here. This is fully saturated. That's how much water you need. This person is irrigating, it looks like at about trying to do 30 centibars. That's be coming across here. Got up to 40 there. That's too dry, especially in our DG soil.
So there on the graph, despite they call it moisture, they mean tension, really.
What?
On the graph, they call it moisture, but they mean tension.
Tension, yeah.
So the larger the number, the drier the field, the drier the soil.
Yeah, good.
Okay.
Good comment. Okay, I'm gonna skip this. I just took this off their website. Okay, so we have lots of others coming on. There's a lot of companies coming out with different things. 5Tech, I think the Avocado Society is organizing a meeting on August 2nd, but it's up in San Luis Obispo. And one of the topics is using the 5Tech system. So I'm gonna hope to go up there because I don't know very much about that system. I just want to put this in here because we are not endorsing any product. We do research with products, at least Jerry did, but Ali does. But we not recommending that you buy anything. Okay, so the second thing is that's frequency. You figured out how often to irrigate, how much do you irrigate. That's why I passed out that the instructions you can use the CIMAS there. CIMAS stands for California Irrigation Management Information System. So we have all these stations around California collecting data. It's all kinds of factors that go into this: the amount of sunlight, the amount of wind, relative humidity, temperature, high temperature, low temperature, that kind of thing. It goes into a formula, calculates what they call ETO. That's evapotranspiration. And we multiply it by a KC, that's a crop coefficient. And I think all the farm advisors, a lot of the specialists have worked on their particular crops to come up with a crop coefficient. Mary Lou Arpaia and I have, and our crop coefficient right now is standing at about 0.86 for avocados. Chile, I believe, is around 7.1 to 7.5, somewhere there. So different countries have come up with their own crop coefficients. And I'm going to go through more rest. This is what the website will look like on avocadosource.com. And you go to irrigation tools and you basically work your way through this. My paper I passed out is just a step-by-step process. If you follow that just exactly, you'll come out with the right answer. And that will tell you, let's say you want to know how much water you used in the last 7 days. Okay, you put that in there, calculate the amount of ETO for the last 7 days, multiply times the crop coefficient, and you'll come up with how much water your trees use. Now, assuming the weather's the same, you can put that exact amount back on. If it's higher, then you got to add to it. If it's lower, you got to reduce it a little bit. But that's a good guidance. It's good for new growers. Just to get them started. Once you know and understand how much water your trees need and is using, you can usually stop doing that and just kind of go. I had a grower tell me, yeah, I started with that and it was really good, but then after that I went by guess and by golly and it's working out just fine. So okay, I just want to have a few things to remember. Avocados do use water during the winter if it's not raining. Sometimes we don't get any rain, but it's not a deciduous tree. It keeps the green leaves on, and so you are the rain. You don't use much, but you still need to put some water on. And I've got water use changes constantly, the temperature, all these other things. Setting a time clock is, I don't think, a great idea at all. I've dealt with a lot of, especially older growers. They set a time clock and it comes on at the same time, but it's twice as hot this week as it was last week or whatever. And they have forgotten how to change the time clock. They lost the directions. They have all these different basic time clocks out there. And I haven't been much help for them, I guess. But if you're going to use a time clock, it's fine, but just be aware that you've got to change it according to the weather. Okay, and then water use changes according to the number of leaves. So as your trees grow together, they get kind of maxed out. Sometimes I saw one of Ali's papers, I think one of his grows had 94% leaf coverage. That's about max. And you're not going to use much more water than that. As they age, the trees are going to grow up, but they're going to have the same number of leaves. And that's how much water you're going to be using. When you plant little trees, of course, you don't have that many leaves, so you can greatly reduce your water use and just expand that as they grow. Control weeds. Weeds are using water. I saw one paper from UC Riverside. They were looking at water use in citrus, and up there they were using about 3 acre-feet per acre per year with no weeds. When they had the weeds out there, they had to increase to 4 acre-feet. So the weeds were using an extra acre-foot of water. We don't have that problem really in avocados much. They cover with shade. We don't have that many weeds once they grow. Okay, the guessing method. It's pretty common when people do that. I'm going to show you a couple of slides here what happened with the guessing method. So this is in Fallbrook. This is how much water we're using. It peaks out in July, August, and starts coming back down again. This was when the grower was guessing here. He still saw all the salt burn on here. He thought he better irrigate a lot to help get rid of that salt burn. It's too late for that. You know, the salt's on the trees and in the trees, and those leaves are gonna drop anyway. So you reduce it back up and down all over the place, and you can kind of calculate how much extra water they're using, that they're paying for, they didn't need. Okay, this is another one. Way too much water late in the year. This person probably had a lot of salt burn the previous year. They learned their lesson. They better irrigate heavily, but that wasn't needed either. All you need is to follow this kind of green line and add some extra to it for leaching. This was done by the Mission Resource Conservation District in Fallbrook, and they go out and they analyze grower systems, and they give you recommendations how to irrigate better. And it's a free service, by the way. I'm going to go just a couple more minutes and then I'll have. Okay, so I just have highlighted here. The last one is trees on sandy soils need to be irrigated more often. That's the big lesson here, because on these decomposed granite soils on these hillsides, you really have to be on your game as far as a grower. You can't just sit back and relax. You got to really watch what's going on out there. I'm going to skip that here. Oh, this is a pressure regulator in a sprinkler. Has a little silicone disc in here. It goes in, and these are very commonly used now. I think we were back in the late 90s. We were probably the first ones to use these things. High pressure. If the pressure is high, it kind of pushes on that silicone disc and presses it and it stops the water flow going through the sprinkler or reduces it. When the pressure is low, the silicone disc flattens back out again and increases the water flowing through. And we did a reclaimed water trial here in Escondido on a hillside, and because of our design, we had to have our sprinkler lines going straight down the hill, not on the contour like you're supposed to do. We have them straight down the hill, and we had these on, and that's a net, I believe a net bin, and we had 93% efficiency. So almost every sprinkler is putting out the same amount of water, which surprised the heck out of me. Pressure regulators, you'd have one of these on every lateral line, I think. And that's when you're on a hill and you have your main sub-main going up and down the hill. And you should have one of these on every single lateral line. And that means you won't get too much water on the bottom trees, and the top trees will all have the same amount of water when you turn the system on. Let's see. Okay, just lack of a pressure regulator. You see that a lot of times. Oh, okay. I think I put this in here to tell you, there is an arrow on here. You can put them on the correct direction. So the arrow says which way the water is going to go. I've seen some of these put on backwards. So let you know. Okay, so, and then I've just got check your systems and flush your lateral lines, clean out your filters, and repair your sprinklers. And repairing sprinklers is almost like a full-time job too. We have people walking through groves and pickers, and they step on these things, and farm advisors step on them. If a farm advisor steps on one and breaks it, just complain, and they'll come back on their weekend and fix it. Yeah, I've had experience with that. Okay, so I think I'm going to stop there. Like I said, I have a full hour talk here, but I wanted to give you the basics for scheduling, and have Allie come up and get his thing going here.
Hey Gary, are you leaving?
No.
Do you have any more of those handouts?
Oh, yeah.
Sitting here. And then this one. And then exactly what they're gonna say, this. Isn't that right? And to hit that. But then they cannot see. With the recording, they cannot see it. It's totally different. I don't know what they're talking about.
Thank you. And good afternoon, everyone. My name is Ali Montazar. I am Irrigation and Water Management Advisor in South California, covering Imperial, Riverside, and San Diego counties. So which means I'm working with very diverse cropping system, environment, and different crop. And avocado is one of the most interesting ones. And I started a large-scale project since last year. So we have now more than 1 year data, and I will share with you what we learned so far, a couple of things. And we will have another irrigation, avocado irrigation workshop, I believe, in July in Ventura, and August right here. But the date still is not clear. But we will have more, comprehensive workshop, what we learn, and we have a 3-hour avocado irrigation workshop in August. But let me start with, it does work.
With asking Jerry, how do I go forward with these slides? Right, that's what we're gonna say
Yeah.
right now? Oh,
Okay, good. Well, thank you. Well, so what I will talk about in this meeting is coming from some of or data. As you know, avocado, it has a very interesting cropping system, mostly in the hilly area. So very diverse cropping system, sloping, and many differences. So we came up with this idea: if we want to develop something and represent the cropping system in California for avocados, we need to expand this study to 12 different sites. So just mature avocados. So we are working with different row orientation, different slopes, anywhere from 0% to 44% slopes. That's huge range. And different, elevation, different tree spacing from low density to high density. And as I mentioned, the elevation, and of course, the water sources from Colorado River right here, wells and reclaimed water in A1. So it can represent also the water source for growers use, because the water source makes big differences, specifically when we care about bleaching and salinity issues. We also did a survey, so we have some information from growers and what's going on in the real world. So let me start with this real example about water management of avocados. So I'm working with the growers. The growers has a delivery system with multiple sprinkler, and he applies 9.5 gallons per tree. That's the irrigation. And this is his schedule. He follows for years this schedule. For winter, 8 to 12 hours once per week, which means he applies about 400 gallons per month, and different months. So that's the plan he has. So when he does this plan, he applies more than 10,000 gallons per tree. For years he's doing this, and we measured last year, and he did the same. So our measurement showed in this field, the crop needs about 7,300 gallons per tree in this specific. So we even consider some bleaching about 10%, because this is a sandy soil. So it doesn't need more than 10%. So still these growers apply 28% more than crop and leaching needs. So 28% in San Diego County, it means we pay about $1,500 per acres more cost just because of the irrigation water. I think that's the main point. We need to focus on that. So how long we can survive or make sustainable, avocado production like that? I think that's the point. We can work on it. All the tools are available on the market, and we are developing, basically try to show you how much really we need water and how we need to apply that water. This is a real example. And we measure. So our survey shows growers, 37 growers responded to this segment. So what we learned, all growers, this is the entire California, they applied between 2.3 to 4.8 acres per acre. As you can see, it's a wide range. So, why 4.8 or why 2.8? Why not between something, So this is the real world we have. Our survey also shows, we asked growers, so what tools do you use for irrigation management? This is what we got. So about 42% they use soil moisture sensors, mostly sensorometer, and a couple watermark, and a couple also other soil moisture sensors. 16% they use CIMIS, 14% irrigation scheduling software. Right, the software Gary showed to us. But also, 55% they go with plant observation and one of those tools. And about 33%, they go with just calendar and they use one of those irrigation tools. So this is also what we learned from growers. And also about 44% of the growers, they don't even know how much water they apply. They don't use any flow meter, and 55% they use flow meter. Because if you want to improve the irrigation scheduling, first of all, you need to know how much water you apply. If you don't have that information, probably it's too hard to improve your irrigation system. So this is the tools Gary also mentioned, good tools. But one issue now we are working on. So this is the equation also Gary mentioned. The crop water needs, it comes from this equation. ETO is grass, well-managed grass, non-stressed grass. Crop coefficient is the crop coefficient depends on many factors. The problem with the crop coefficient is we never develop or update crop coefficient for the cropping system we have in California. And that's why we got this project to work on it. So the objective is to update crop coefficient for the cropping system we have in different locations. How a slope, how orientation, how the canopy percentage makes impacts, because we don't consider those things. And that's why we don't have really the updated crop coefficient. Just to mention why it's important. If a grower mistakenly consider crop coefficient 0.75 instead of 0.65, or 0.65 instead of 0.75. So these growers apply about averagely 1,000 gallons more or less than crop mix. So that's exactly the problem. So it means we really need the crop coefficient. And the objective in this research is to develop and interpret crop coefficient and attach it to this software. When we do this, our growers can have a very reliable tools. So they can go there, they can choose, because if you go to that software, so when it goes to crop coefficient, it puts you in the darkness. So you can use it. You can use 0.85, what Gary mentioned. You can use it 0.8. Why not 0.875? So that's a darkness here. There is no recommendation, real recommendation there, because we never developed that. So we try to develop this based on different variables and then attach that graph and information to this software. And from there, so you have very reliable software to use. So when it comes to ETO, there are a lot of tools. Gary mentioned about CIMIS, even special CIMIS. It gives you the ETO or grass ETO for your orchard. You can also use this spread. It was developed by the National Weather Station. It gives you also the ETO for the next 7 days. It's very important for us because heat makes a difference. So we need to always know what's going on for the next 7 days, not just in the past. So this ETO gives you that information too. It means you can calculate the 7 next ETO of your orchard through this ETO and that software. So the other tools are available now. So as I mentioned, avocado trees are most in the hilly area. So we have variable water pressure. We also have different water demands. Because it's not just about variability, also water demands. If you have, south facing slope or north facing or, west facing, your water demand also is different. You cannot use the same amount of water. In some case, 15% differences when you have south facing and west facing slope. So when you need to consider that you don't need to apply the same amount of water. So that's why we believe we need to use different crop coefficient for the south facing and west facing and different facings. So because of all those differences, you need to, the way you need to do is you need to create as many as different irrigation blocks. You can do it, but sometimes it's difficult. You cannot manage too many. You can go with some, but not too many. Maybe variable irrigation is another approach, but I think it's really difficult for avocado. If you have very flat land like almonds, it's very easy to go with the variable rate, but really it's too difficult with avocado to talk about, at least at this moment. This is the thermal map from one orchard right here, 15 minutes from this building. So we have different colors, you obviously see it. Where we see dark red, it shows there are some stress in the field. So as you can see, mostly on the top here, the trees, some trees are under stress, but not in the bottom here. So this is NDVI map and thermal map in another orchard in Temecula. So NDVI shows how green is the orchard. So when it's greener, it means the crop coefficient is higher or water demand is higher. When the thermal map also shows the stress, where the plants are under stress. The red, dark red shows more stress. So obviously you see water demand variable in that orchard. The same water stress also variable. It means we have a lot of variabilities in the hilly area. In terms of water stress and water demand, it's really not easy to manage, water more efficiently in the hilly areas. So this is another issue where we have soil moisture sensors. So I have this graph. So it's in 18-inch depth. 2 soil moisture sensors, just 2, 3 next to each other, shows what it said. One of those graphs shows the soil is always saturated on that depth. The other says that no, it's dry, just apply water. So one of the issues in the hilly area is that even the soil moisture sometimes doesn't work well because we have rock, the water don't flow around the sensors and just mislead you sometimes. So that's why if you want to use soil moisture, you need a couple of them, not just one, because sometimes it can easily mislead you. Right here, I found this, and then I asked, okay, let's put more. But I use this just for training to show you, we install this, not anyone, researcher install, and still it can mislead us. So sometimes even soil moisture, are not reliable. This is the soil salinity. We have different sorts of water. We have different soil texture and types. It means we always have different type of also salinity issues. If you look at in the left side, we have sandy loam. In the right side, we have silty loam. So the EC you see in the profile are differently. So how I should deal with the left side soil or orchard and the right side. So it will be different. So it means we cannot just easily, go with a number or leaching fraction or amount of applying water for bleaching, because we need to consider these. And we try, so currently we did salinity study in all these 12 sites. So the next few months we do analyze that, and we come up with some calculation and some recommendation. Really we need to do what in different conditions. So we will develop that information in the next couple of months. So, but the good news this year. So the top graph shows our soil moisture sensors. 1 year, from March last 2022 to March right here, this year. And the bottom one shows salinity. You obviously see, the rain contributed, well to us. as you can see, even without any irrigation in this orchard, the soil profile is good. And also, very interesting, the salinity from right here started to dramatically decline. So which means the rain also contributed to leaching. So our orchard now are full of water and there is no salinity issue. And this is what the trend we found in all 12 sites. From Ventura, Irvine, Temecula, and Sandy. So all shows, we have a very good condition this year. So the salinity, always a concern for you. But these graphs are coming from my other project in Imperial Valley. Always you need to think leaching is for main tools or the effective tools growers they have for salinity management. Look at what happened here. The red line shows this is a drip irrigated onion field. So the field is silty clay. You don't have this here. Mostly, you have sandy soil. So your problem is different. But look at what it did. The growers applied 1 foot of water or 12 inches to leach that field, heavy leaching. So the salinity was the red graph. And after I did this survey, before leaching and after leaching. The red line shows before leaching. The blue one shows after leaching. So look at how effective was the leaching. So bring down the salinity from 10 decision per meter to about 1.5. So it means it's really effective if you have a good drainage system. So the drainage, your leaching is the only tools you have. Look at the result on chloride. The same effect. Chloride is very leachable. So which means if you do the leaching, it can also bring down your chloride. Again, before leaching and after leaching. The entire soil profile, the chloride declined after leaching. But one of the other issues, we have this, in San Diego County, maybe some in Riverside County, but not in Imperial. So, and that's about the location. We have a very unique, specific geography in San Diego County. We have different elevation. If you look at, I showed this in the past, if you look at just 3 locations, Fallbrook, Escondido, and Pine Valley, they are different walls. So just focus on July, that's the ETO from CINIS. In July, water needs in Pine Valley could be about 40% more than Fallbrook, and about 25% more than Escondido than Fallbrook. This is what ETO says. If we just consider one lemon orchard in these different locations, Pine Valley, because we have it in Pine Valley and Fallbrook and Escondido. So the amount of water and irrigation schedule you need is entirely different. In Fallbrook, you need about 3.8 gallons per day per tree in July. But in Escondido, you need 43. And when it goes to Pine Valley, it's 54 gallons. So it means, it's really, we need to consider that. It's not that easy. We cannot make a recommendation, 2 times a week and this, the amount of water. You obviously see, we need to consider. This is one orchard, avocado, we are working. This is the information, 11 years, 44% slope, and the elevation 75 feet above the sea level. And this is the crop water use we made. So you never see this graph in Imperial, because there is no significant differences over time. But here you have cloudy days, in May and in the middle of the summer, cloudy days. You see how fluctuation you see? We never see something like this in Imperial or east side of Riverside County, but you see it here. So even during the heat, we had 2 heat waves in Escondido last year, one in late June and the other in early September. So our data shows we had, that way we also had rain. But my point here is the average crop water consumption in this orchard was 44.8. And among all the stations we had, this orchard had the most water use. It means the crop coefficient we develop is the maximum. All the other orchards are below this, and I will talk about that. So this is our standard at this moment, very high water use. So it means you should expect your orchard needs water the same amount or less. This is or baseline at this moment. This is another orchard in Temecula. Of course, the spacing is different, younger, 8 years old, and the slope also is different. This is the graph we have. And the average crop water use for the Temecula one was about 24.2, just 25 miles away. But there are different elevations. You know, that one is in Temecula is 1,500 above the sea level. The Escondido is about 770. So there are, you know, different elevations and also spacing and everything. So this is the water demand compared to water applied in two sites, one in Ventura and the other in Escondido I talked about. So I have, in this graph, I showed data from, you know, mid-February by mid-May. So it shows there is significant difference, you know, the crop water demand right here and Ventura is has a difference about 15%, even during these months. I don't know where it goes, you know, during summertime, but it shows there is significant difference even during this month, you know, all the clouds we had here, they had their rainy days and everything. But we see 15% difference between the water demand of one orchard, avocado orchard in Ventura and here. So this is the water applied, which means rain and irrigation. So site one is in you know, the right here, and site two is Ventura. So if we consider as an indicator water applied to actual ET. So right here we have 176%, and in Ventura 188. It means we are in very good condition this year. You know, it means the amount of water crop needed during these months from early year by now, you know, we have about, you know, 200% more water. So which means you really didn't need, you know, irrigation water, just a couple of times probably from mid-April by now, not more than that. In both sides, you know, but in Ventura we had a better condition. This data also shows. So why we have different crop, you know, water needs? It shows the net radiation. The net radiation is the main factor for water demands. So it shows one side, the top in Escondido, right here, and the bottom one in Ventura. You obviously, if you look at this, you know, data shows the differences because the net radiation, you know, the energy comes from the sun, and that energy, you know, cause transpiration or crop water need. You obviously see, you know, differences. So if we see some differences in different locations, we need to you know, to talk about, okay, what it makes differences. So part of that's the energy comes from the sun. So our calculation shows during just these 96 days from February by now. So in Ventura, in here, we had about 8.2% more net radiation energy for evapotranspiration right here in Escondido than Ventura, 8.2. But I showed you 15% water demand. It means it's not only about the sun, it's also about, you know, humidity, it's also about the wind, it's also about, you know, other things. Because we have 15% more water use, but 8% comes from the sun. So our data shows the temperature and wind speed, the air temperature in here was 15% more than Ventura. The wind was 16% more than Ventura. And the humidity, the air relative humidity was about 1% less than Ventura. So they make contribution, you know, in crop water use. So they make the other 7% of the needs, you know, with this field. So the canopy also, it make a difference, you know, Gary mentioned about. So which orchard we are talking about? If you are talking about the top one with 96.4%, very high density, the trees are 10 by 12 feet spacing. So the canopy percentage goes up. You know, there's huge light interception from the from the sun. But the bottom one is in air one, just about 50% cover percentage. So when we do, scheduled irrigation, we need to consider those things too. So we try to develop relationship between the canopy percentage and also the crop water needs. It shows, good information for you. You evaluate, about your field. You see, okay, my field is about 60%. We provide also some example, you can estimate for yourself. I am with 60% canopy and I use this crop coefficient. So this is what, we try to develop in the future. This is the crop water use, just, again, two sites, one in Temecula, one in Escondido. In July, we found 40% differences in water demand between these two sites, just in July. 40% make a significant difference. It means your irrigation scheduling is different. The amount of water in each irrigation event and the frequency will be different. The crop coefficient. This is what we developed for Escondido. And as I mentioned, this is the maximum crop coefficient we have by now. All the crop coefficient we have now for the other side are below this graph. So if you look at, you see the crop coefficient in different time of year are different. So it means we really cannot use just one crop coefficient for the entire year. So this information shows in early spring, we have a higher crop coefficient, and during summer goes a little bit down. And again, during the winter time, because we have a very unstable weather condition, we have a very wet soil, and we have a lot of winds. So you see even crop coefficient goes up during winter time and late. So I think we can develop, a graph with 3 different crop coefficient in different time of year and make the life easy for our growers, because the crop coefficient change daily, but who wants to use that? So we try to develop just, a graph with 3 different crop coefficient in different seasons and make the life easy. And as you can see right here, you see how uniform is during summertime. So it's very uniform, from early June to late September, the crop coefficient is very, smooth, and you can use really one number for that. So another point I would like to mention, because we have the data to discuss this. So the data we have in Escondido from this orchard shows. So from April, let's divide the year in 2 different sections. April to September, 6 months, and October to March, another 6 months. So this data shows 63% of the annual water used by avocados are happening the first 6 months, April to September, and about 37% happening from October to March last year. So I don't know about this year, but after 2 years, we can, evaluate what's going on. As Gary mentioned, really crop needs water during winter time. The data obviously shows it needs. So, but the good news with this year also shows, if you look at this information, it shows this. So the crop water use in this orchard was about 3.7 acre-feet per acre, the total crop water use. But interesting, 55% of the crop water use during December to late April happened by rainfall. So it means you need to consider that. If you consider that in this orchard, which has the highest water needs among whatever we have by now, so the irrigation water is about 2.9 acre-feet per acre last year, by just May 15th. It means this grower needs to apply just 2.9 acre-feet per acre of that water, and the rest comes from the rain. But when we don't have that rain, so that 2.9 goes up. Sometimes you need to apply 3.5 in this field, changing between different values. So I think this is my last slide. We also developed, we have the ET, we have the soil moisture sensors, but we also need to look at what the reflection of the real plant to evapotranspiration or transpiration. So we are using different tools. This is one of the tools, the sap flow. It shows the actual transpiration. So we try to develop a relationship between transpiration and what we measure from the other tools. In the future, This tool is about $700. If we have a reliable relationship between the actual evapotranspiration and this, I think at the end, maybe we can recommend growers to use such a, very cost-effective tool, and also ET and soil moisture, and do a good job, with irrigation management. But still, I don't recommend, because we need more data. But look at, what happened here. So every day, so from 6 a.m., 6:30, so transpiration started. And then at around noon, 11:30 to 12:30, different time. So the transpiration goes to the maximum. And from 1 p.m. again, the transpiration starts declining by evening. And during the night, stay at the minimum, but never goes to zero. So it means plant also, even during night, takes some water, never goes to zero. And it's happening every day. But very interesting, on that spot, you see 20% spike of transpiration just around noon. It happened during the heat wave. It means during the heat wave, tree look at for a time or a wind or something to just cool down. It means that tree in that 2 days, it found an opportunity to increase the transpiration just in 30 minutes, 40 minutes to cool down. And plant is very fine, and that data also shows. But my other point is, this is for September. If you remember, we had a heat wave last September here, and then the rain came just after 2 days. So look at the transpiration, dramatically reduced by 300%, less transpiration. So we track all those things. I think so far we have good data, to discuss that. And I think that's all I have for today. Please.
On this, as you go through the year, your crop coefficients change. Are you going to be able to add that into the avocado source software?
Yeah, this is what we try to do. We will develop. We don't need to add it. We develop some writing stuff. We attach it to that software. So we recommend them to growers. When you go to crop coefficient, you need to choose it. So you need to look at that graph we develop and we recommend in different conditions. It means you can, use those numbers based on your.
Okay.
So you don't need to, just evaluate by yourself. We have literature now, so growers they can use it. Yes, we will attach that information to them.
Well, that'd be good.
Yeah, this is the objective.
Does recycled water have more chloride in it? In one picture I saw there was more.
That's good. That's a great question. I think this is that you need to consider in the future. In terms of calcium, magnesium, we saw less in reclaimed water. We saw, more nitrate and chloride. It means if you use reclaimed water, you don't need to apply that much nitrogen because it's more than enough. And also chloride. And that's why we found in A1 more chloride and salt issues than
You think that'll be the case in Escondido?
Well, the good thing with the Escondido is, your soil is sandier than there. So I think the problem will cause by that water should not be in that level.
I think you're going to do reverse osmosis on that water and send it out to the ocean, so it's going to reduce that chloride quite a bit.
Well, the water sample shows it has more chloride and nitrate than Colorado River, because we have all that information in the soil and the water. So the airborne water, reclaimed water, has a higher. I don't know, what reclaimed water we will have in the future. But what we have from that data shows the chloride and nitrate is more than chloride.
So up north, are they doing RO to
Well,
water?
that's district water.
Because we're gonna get RO water here for our reclaimed water, but up there, they're not doing RO.
I think they do,
The quality.
but I don't know in that which level or. But both in soil and in water, we found, just to mention the Colorado. The Colorado River here, but I need to mention this. The Colorado River you have here is really different from Ontario. Because I think that this street is doing something, because I have the information here and also in Imperial. So the chloride, the calcium, magnesium, all those are different, even though we call it chloride here. So I think you are good with that. But my point, the chloride, in that water you using for this field is about 109 part per millions. But in that water in A1 is 190 part per millions. So obviously, the chloride is more. It means we add more chloride in that. And we found also more chloride in the soil too. That's good. But I don't know about, the water you will have here. But even if you have that water, because your soil is sandier than those fields, your problem should be lessened.
Oh, find out in August, I guess.
In that reclaimed water trial we did here, we compared district water with pure reclaim, and over a 5-year period, we had a 40% drop in yield on the reclaim because the chloride was so high, and so to the point where the grower was complaining, and so we did a 24-hour irrigation, and that really acted like a rainfall. We really got a lot of that out of the soil. The next year we set a really heavy crop. So but I think the system they're talking about here is that they're going to do RO and send the brine down to the ocean, and then pipe the water, the better water back up behind your Escondido here. I don't think it's in operation yet. I don't know for sure. August. Yeah, that would be interesting.
Yeah, until we don't have that water, I think it's hard to talk about. Because as I mentioned, even though you have Colorado River, your quality is different from Imperial Colorado River water. Because the district is doing something.
Allie, do you think the Colorado River is getting more saltier as time goes on?
I think so, when we have less water, the volume goes down, so the salinity goes up, the AC goes up. That's very, I think we should have a salty water in the future. If the total volume goes down. That's one of the issues, with the limited water source, always. We should face more saltier water.
Is there a pressure compensating riser? Because I'm using 2 different styles of emitters, a microjet and this adjustable orbit head. And I'm getting different flow rates. If I could put a pressure compensating adapter on top of my 1/2-inch riser so that I could use whatever emitter I want, does such a thing exist? Like the Netafim,
I think
if there was, what
you are the good person to answer that question is expertise with those.
I can tell by his look, it doesn't exist.
There's small pressure regulators. If that's what you mean.
Well, to put on top of the 1/2-inch riser, and then I'd put on my microjet or my orbit emitter.
You're better off just buying a pressure compensating emitter. They're too expensive to buy a real regulator. That makes
And
sense?
they're $5 a pop. for
Yeah,
the orbits.
So go buy a pressure compensating emitter and put it on every riser.
Yeah, it's expensive.
I don't think they're that expensive, are they?
Oh, they're $1.
$1?
Yeah, or less. Depends how many you buy, right?
Netafim makes them,
Yeah.
Toro, I think, is less expensive.
because the Netafims are the spinners.
I think other companies have got into that now too.
Netafim's gonna be one of your most expensive.
And what's the other brand?
Toro is probably the least expensive.
From Australia,
Mhm.
they have different tips
Mhm.
within the emitter that regulates the pressure.
I think Jane company also has it.
The fitting in there,
Jane?
black and blue, different colors.
Mhm.
Perhaps it's less expensive.
I have a question. Did you get any of your water from the Ubia
water district? In,
Uh.
in your tree, on any of your trees?
In Palma Valley,
What's that?
in Palma Valley,
Yes. Because they get part of their water, about 50% of their water from Palomar. So what does that mean, the people in that water district? They're getting different water, part of it's from Palomar that changes daily.
I don't know. I don't know what their salinity content up there is, but it's a lot hotter up there. I know their ET is gonna be hotter.
Jerry, we have 3 wells at our ranch in plus district water. Those 3 wells, and they're not that far apart, half a mile apart. The salt concentration is different on all 3 of them, and it changes. Yeah, you have to do it all the time. You have to watch all the time.
I was looking at a grove last week and, this particular grower has a reverse osmosis system put in. And he showed me, he had a salt meter in his hand, which I recommend, by the way. All the growers should have these, but the salt content, off the RO water was 342 ppm. And from his well, it was 2,200 ppm, and from Keys Creek, it was 2,400 ppm. So that is way too salty to irrigate from that particular well he had, you know. But the RO is looking good, but as far as I know, maybe one of you guys know, if you can't get rid of the brine out of the ocean asphalt, you can't put it in the creek. I think you can put it into a lined pond and let it evaporate, or I think it's still legal to put it out on what they call spray field, just a blank place and spray it out there. Or if you find something like barley or something that will take up salty water, but you happen to know the answer to that? It's legal?
Well, I don't know. I don't think it's legal.
The answer is, it depends who you ask.
Well, maybe don't ask.
I'm gonna leave it at that, yeah, exactly. Some people use it to spray roads for that control, which is kind of cool, you know, because then also they say, okay, the salt also keep together the dirt, so it controls that even more than it controls normal water. But then I guess it begs the question, what happens when we get a storm and, you know, all the water flushes out into the creek?
Yeah.
But if you don't ask, nobody ask that question, so I think you can still do it. Some people do just a leach field, like if it was a septic tank. But again, I don't know if it's legal or.
They use ponds and everything.
Yeah, I mean, we're in the realm of. It depends who you are.
I have a can you hear me? I have a question from the Zoom call.
Go ahead.
Yeah, go ahead.
So I bought an old Grove and I had some pressure meters that actually set in the 1-inch riser and screwed into the 1-inch riser. Is anybody familiar with those, or where there might be a source of those kind of meters?
Pressure meter.
I got everybody stumped, right? It's a water pressure meter, and it just screws into the into a 1/2-inch riser. So it makes it really easy to measure pressure you got on your Grove and your laterals. And the meter just screws right into the top of the 1/2-inch riser.
I haven't heard of that.
Okay, like it's a pressure gauge with the hose threads. So you can just.
That's right, pressure gauge with a hose threads, and the meter itself just sets in a 1/2-inch riser. And how I found this, I bought an old Grove and there was a couple of meters in there like that, and they're excellent in that they just sit right in the riser and you can measure pressure, but I can't find them anyplace.
Yeah, I would probably call Mission Resource Conservation District and ask them that question. I think you do have them.
Okay, okay, that's thanks, that's good advice.
Where do you get those salt meters? Handheld?
Oh, you look on, yeah, just look online for a salinity meter, and you have all kinds actually. I'm not sure what kind of particular one.
So it's a probe into the soil or a sample of the
No,
code?
no, he's putting water from his well on a little disc or cup, and they're measuring the EC.
For water, there are a lot of tools, it's reliable in the market.
The challenge there is that some people use ppm for salinity, and some people use deciments per meter. And there's some kind of a conversion factor that also depending who you ask,
Exactly.
it's between 640, some people say 700. But so when, I think earlier Gary mentioned about 300 ppm, the reverse osmosis water, that would correspond to about half deciments per meter, because one deciments is about 700 or 600 ppm. Again, depending who you ask, we have a 600 here, and other people will say 700, so
I use 640.
all right, yeah, it's good, thank you. So that's a problem there, the conversion factor, depending who you ask, they use different units, so be careful, all call us. And you get a different answer depending on which one you call.
You know, with reverse osmosis, you can get the water almost down to pure water. I mean, no salt at all, but they add some back in, so you get some of the minerals, like calcium and magnesium. So they don't want it completely pure.
Somebody told me that it's completely pure, it doesn't infiltrate
Yeah.
also.
The pure water is not good for irrigation. You always need those things.
What do you do with reverse osmosis? What do you do with your throwaway water then?
Well, that's what we're talking about, the brine, what you can legally do with the brine. Yeah, and the county is checking the creeks and streams, and you'll get fined big time if they catch you doing it.
All right, can we go home now? All right, thank you, everybody. Thank you, Doctor.